Hello, everyone. I am Lyra Stone, a digital persona at Kadel Labs. Today, we are going to dive deep into a critical topic for the banking sector, ensuring the security of personally identifiable information, or PII, through a robust data security framework. At Kadel Labs, we've harnessed our experience in developing secure systems to create a comprehensive solution for PII security rooted in zero trust principles. Let me walk you through today's agenda. Our discussion will focus on four main topics. The last or fourth topic is covered in part 2 of this series so that we can have a detailed deep dive into tools to be used for PII data security. Our first topic is core principles of zero trust. We'll explore the fundamental pillars that support a zero trust architecture, focusing on how they ensure the security of PII in banking. Next, key building blocks of zero trust. We'll break down the critical components of zero trust, such as identity management, microsegmentation, and encryption, to see how they contribute to a secure environment for sensitive data. Next, practical use cases for PII security in banking. We will look at real-world scenarios that demonstrate the application of zero trust principles to protect customer data in various banking processes. The fourth topic is Toolkit for PII data governance. In part 2 of today's session, we'll discuss a specialized toolkit that includes AWS and Azure solutions to effectively manage, protect, and govern PII within the banking sector. Now, let's move into the core principles that form the foundation of zero trust architecture, specifically in the context of securing PII in banking. At a high level, there are 3 key principles that guide zero trust for PII protection. Verify explicitly. This principle requires constant verification of identity for every access request, leaving no room for assumptions. Least privilege access. Access to sensitive data should be limited strictly to what's necessary for a role, reducing exposure and risk. Assume breach. In today's threat landscape, we operate with the assumption that a breach is inevitable. The goal is to limit the damage through microsegmentation and other containment strategies. We'll cover each of these in more detail in the next few slides. Let's dive deeper into the first core principle of zero trust: verify explicitly. This principle emphasizes the need to continuously verify the identity of every user, device, or system attempting to access sensitive information. The primary way we enforce this principle is by requiring multi-factor authentication, or MFA, for all customer logins. This ensures that even if one authentication factor, like a password, is compromised, additional verification, such as a one-time password or OTP or biometric data, is required to gain access. Take the example of securing customer account access. When a customer logs into their online banking account from a new device or an unusual location, the system can require additional verification steps, such as OTPs or biometric authentication, to ensure that the request is legitimate. As a security action, it's critical to implement MFA across all customer logins for online banking platforms. By enforcing this, banks can significantly reduce the risk of unauthorized access and protect customer PII. Now, let's explore the second principle of zero trust: least privilege access. This principle ensures that employees have access only to the data they need to perform their roles, minimizing the risk of exposing sensitive information. By implementing role-based access control, or RBAC, we can restrict employee access based on their job responsibilities. This approach limits unnecessary exposure to sensitive customer data, reinforcing security. A practical use case is employee access to sensitive customer data. For instance, tellers in a bank only need to see customer names and account balances to perform their tasks. On the other hand, a loan officer who deals with more detailed financial data requires access to credit histories. This differentiation ensures that data access is strictly controlled. To enhance security, it's essential to implement RBAC so that employees only access the information required for their specific roles. This not only reduces the risk of data breaches, but also ensures compliance with data privacy regulations. Now we come to the third principle of zero trust: assume breach. In today's cybersecurity landscape, we operate with the assumption that a breach can and will happen. The focus is on limiting the impact of a breach when it occurs. One of the most effective ways to contain the damage is through micro-segmentation. This technique divides the network into smaller, isolated segments. Even if an attacker gains access to one segment, they can't easily move laterally across the network to access other critical systems or data. For instance, in the scenario of lateral movement prevention, micro-segmentation ensures that an attacker who breaches a specific system can only access a limited set of resources, drastically reducing the potential impact. The key action here is to enforce micro-segmentation across the network. By doing so, even if a breach occurs, access is confined to specific segments, ensuring that sensitive customer data remains protected. Now that we've covered the core principles of zero trust, let's briefly look at the key building blocks that support these principles and form the backbone of a secure zero trust architecture. We'll focus on four critical components: identity and access management, or IAM, ensuring that only verified users have access to the network; micro-segmentation, isolating parts of the network to contain any potential breach; data encryption, protecting sensitive data, both in transit and at rest; endpoint security and device posture assessment, ensuring that all devices accessing the network are secure and meet predefined security standards. These components are integral to implementing zero trust effectively, and we will explore each one in more detail in the following slides. Let's start with the first key building block of zero trust: identity and access management, or IAM. Under this, we'll focus on two crucial strategies: privileged access management, or PAM, and just-in-time access revocation. First, we have privileged access management. This approach enhances security by granting system administrators only time-limited access to the resources they need to perform their tasks. By limiting the duration of this access, we reduce the window of opportunity for unauthorized users to exploit admin privileges. The second point focuses on just-in-time access revocation. This technique ensures that once a system administrator completes their privileged tasks, their access is automatically revoked. By enforcing this, we minimize the risk of ongoing access or misuse of administrative privileges. Automating this process significantly boosts security, preventing unauthorized access from lingering. Now, let's focus on the second key building block: micro-segmentation, and how it strengthens zero trust by limiting lateral movement within the network. This method plays a pivotal role in enhancing security by isolating different types of data, which creates tighter control over access and movement within the network. Microsegmentation allows us to segregate different types of data, creating isolated segments for heightened security. This ensures that critical business entities, such as customer data, transaction records, and internal systems, are protected from unauthorized access. For example, consider transaction data protection. Sensitive information like mortgage applications can be isolated from the core banking systems. By doing this, we minimize the risks of unauthorized access, ensuring that sensitive data remains protected and separate from other systems. With microsegmentation, we reduce the exposure of critical data. By creating these virtual barriers, we effectively contain any potential breaches, making it harder for attackers to access sensitive areas of the network. This also results in enhanced data security. By establishing virtual boundaries around specific data sets, the organization creates a more robust defense mechanism. This strengthens the overall security posture, ensuring that even if one area is compromised, the breach does not spread further. Now, let's move to the third key building block: data encryption. Encryption is vital to ensure that sensitive data remains protected at every stage, whether it's in transit, at rest, or in use. First, encryption should cover a wide range of data types, including data, documents, and database metadata. This ensures that everything from customer records to internal documentation is encrypted, safeguarding sensitive information from unauthorized access. Next, it's critical to apply encryption at all locations, whether the data is rendered in a browser, stored at rest in databases, or in storage systems. By encrypting data across the entire lifecycle, from transmission to storage, we create multiple layers of defense against potential breaches. Finally, let's consider secure data transfer. When data is being transferred between a client and server, we can use methods like TLS SSL encryption. This obfuscates the data during transmission, ensuring that even if intercepted, it remains unreadable to unauthorized users. The final key building block of Zero Trust is endpoint security and device posture assessment. This ensures that all devices accessing the network are secure and compliant with predefined security policies, which is crucial for protecting sensitive banking data. To safeguard remote access, implementing Zero Trust Network Access, or ZTNA, is essential. By enforcing strict remote access policies, we can ensure that only authenticated and authorized users can access sensitive information, regardless of their location. Device posture assessment plays a key role in ensuring compliance. Automated health checks are conducted on devices to verify that they meet security standards. This includes checking for encryption, up-to-date antivirus software, and applying necessary patches before allowing access. Let's consider an example. A remote loan officer can only access customer data if their device passes a health check. This check verifies if encryption, antivirus protection, and necessary patches are in place. By ensuring the security of the device, we significantly reduce the risk of unauthorized access or data breaches. Now that we've discussed the key building blocks of Zero Trust, let's shift focus to practical use cases for protecting PII in the banking sector. These examples show how Zero Trust principles can be applied in real-world scenarios to enhance data security. We'll be covering 3 critical areas. Just-in-time access implementation, limiting access to sensitive data based on immediate need. Data masking for front-end employees, ensuring that employees see only the necessary portions of customer data. Behavioral analytics to prevent fraud, using analytics to monitor and detect suspicious behavior before it results in fraud. Each of these topics will be explored in detail on the following slides. Let's now explore our first practical use case, just-in-time access implementation. This approach ensures that access to sensitive customer data is granted only when absolutely necessary, significantly reducing the exposure of PII. In the context of loan approvals, temporary access can be granted to loan officers only while they're processing the loan. This means that access to sensitive customer data, like financial histories, is available only for the duration of the approval process. Once the task is completed, access is revoked, enhancing data security. To further enhance security, automatic revocation of access is enforced after the loan approval process is finalized. This ensures that once the officer no longer needs access to sensitive data, such as financial histories, their permissions are immediately withdrawn. By doing so, we minimize the risk of unnecessary access and protect customer information. Next, let's dive into data masking for front-end employees. This practice ensures that sensitive customer data is hidden unless there is a specific need for full visibility, minimizing the risk of unauthorized exposure. One common example is in customer service. When handling account inquiries, data masking ensures that representatives only see partial data, like the last 4 digits of a Social Security number, RSSN, unless higher authorization is granted. This approach protects sensitive information while still allowing the representative to assist the customer. In payment processing, data masking can be applied to protect credit card numbers. Employees handling transaction verifications will only see the last 4 digits of a card number unless additional approval is required. This ensures sensitive financial information remains secure, only revealing what is absolutely necessary. Let's now look at how behavioral analytics can be leveraged to detect and prevent fraud. By continuously monitoring user behavior, we can identify unusual patterns that may indicate fraudulent activity. One way to use behavioral analytics is to detect suspicious login activity. Machine learning algorithms can monitor login behavior, comparing it to the user's normal patterns. For example, if a user typically logs in from the same device or location but suddenly logs in from a different environment, the system can flag this as suspicious. Another example is triggering alerts for unfamiliar locations. If a login attempt comes from an unrecognized or suspicious location, the system will prompt further verification, such as multi-factor authentication, before allowing access. This adds an extra layer of security and helps prevent unauthorized access. As we conclude this section, let's recap what we've covered so far in the Zero Trust Data Design Framework. This framework provides a comprehensive approach to safeguarding PII in the banking sector, ensuring that sensitive information is well protected. By applying the core zero trust principles, such as verifying explicitly, enforcing least privilege access, and assuming breach, combined with the practical tools we've discussed, banks can greatly improve their data security posture. These principles, when integrated, form a robust defense against the evolving threats that banks face today. This wraps up the first part of our discussion. In the next section, we will dive into the Cloud Toolkit for PII security, which will further enhance your data protection strategy. Stay tuned for part 2.